One area that gets a lot of confusion is the concept of chipsets. So let me clear that up for you right now. In order to appreciate chipsets, you have to appreciate what was happening before chipsets took place. I've got a perfect example of this right here in front of me. This is a very, very old motherboard. And if you take a look at this motherboard, you'll see that it's got all kinds of chips just covering it. These chips have all kinds of functions. This chip right here does nothing but talk to the keyboard. This chip right here does nothing but talk to the hard drive. This chip right here does nothing but talk to the serial port and parallel port. There's another chip in here that doesn't do anything but talk to the floppy drive. The problem is that having individual discrete components that had single function, well, it made motherboards expensive. So what happened over time is that we began to get VLSA, very large scale integration technologies, that started to take all these different functions and consolidate them. So the best way to understand this is to start with candy. So what I'm going to do, let me dump all this candy out. Now, as we look at all this candy that's laying here, each one of these pieces of candy represents some particular function that's taking place on a computer. This piece right here, this is going to be processing. I'll put that right there. This piece right here, this is going to be the memory controller. This piece right here, this is keyboard. This piece right here is hard drive. This piece right here is going to be serial and parallel ports. So all of these different things, in fact, I'm not even going to use all this candy because if we go back in time long enough, there weren't that many discrete functions compared to what we have now. So I got all this candy. So to make the analogy a little bit tighter, what I want to do is I want to bring a glass bowl in. This glass bowl represents a chip. This chip, remember processing? That's the CPU. Now, instead of bringing out a gazillion glass bowls like we did in the old days, what I want to do is show you, I've got one right here. Yep, here it is. Not quite 20 years ago, Intel came out with this guy right here. This is a very, very famous particular system because this is the Intel 440BX chipset. What they did is, notice there's a lot less chips on here than that board we saw earlier. And what Intel did is they integrated a lot of the functions that were traditionally assigned to discrete chips and put it down into a two-chip group. And that's where the term chipset came from. The 440BX really defined the concept of chipset. I'm not saying there weren't chipsets before it, but the 440BX is what really put it on the map. So I'm going to pull out two more bowls to represent these two chips. Now, there's one function that's really, really important. You see this right here? This is memory controller. This is the function of talking to the RAM to get whatever is on RAM to and from the CPU. Pretty much the definition of Northbridge is based on whoever is handling the memory controlling is the Northbridge chip. The other chip, the Southbridge, would be dumped with the slower stuff, you know, more basic I/O, things like that. So if you needed something done fast, you tended to put it on the Northbridge. So this one here is going to be the expansion slots, old PCI expansion slots. And this here is going to be an AGB connector. And this one here is going to be, what else do I have? Keyboard. So if you went back and looked at the early days, basically you had a CPU which did the processing, you had a Northbridge chip which in particular always did memory controlling, but it would also talk to the higher speed buses, primarily whatever was the hot expansion bus of the day, and then pretty much everything else got dumped on poor old Southbridge. So we would tend to use terms like Intel would use the term MCH, memory controller hub, and then IO controller hub for the Southbridge. But anyway, pretty much everybody copied the Intel idea of two chips. So you would see AMD, NVIDIA, VIA, all of these guys coming out with these two chip sets. The important thing you have to understand is these two chips are designed to work together from the ground up. Collectively, these might be called a 440BX chipset, but each chip had its own chip name. The other thing that was important is that these two chips were designed to work with a very specific type or at least range of CPUs. If you think about it, that's not that hard. I mean, if we're going to make a motherboard and we're going to solder a socket onto it, it's not that big of a stretch to go ahead and socket a particular chipset for that particular class of CPUs that it's going to work on. So this is how life began. And chipsets were good, but new technologies came along all the time. Oh, here's PCI Express. In general, chipsets would always take the newest technology, dump it into the North Bridge, and then older technologies, here's regular old school PCI, would be downgraded into the South Bridge over time. There have been tens of thousands of chipsets designed over the not quite 20 years. And the big difference between one chipset versus another is really, really important. For example, does this particular chipset support DDR or DDR2? It's not the CPU that makes that definition. It's the chipset. What version of USB? How many USB ports? How many hard drives? Does it support video or not? All of these things are important criteria when we're talking about a chipset. But the important thing is that new technologies tend to get dumped into the North Bridge, and then old technologies we get dumped into the South Bridge. In fact, on a lot of systems, all the legacy stuff like parallel ports and serial ports and keyboard and things like that ended up getting dumped into a very specific chip that's for some extent still common on a lot of motherboards called the Super I/O. And it's just always kind of funny, you always see that Super I/O chip on a system. What makes this important is that it's your job to stay up on chipsets. For example, when I went to buy a new system, the hot chipset was the Intel X79 chipset. The X79 had very specific features that were important to me. It supported USB 3.0, it supported eSATA, it supported DDR3 at very, very high speeds and a lot of it. And I go to websites like Tom's Hardware or Ars Technica, and I'm always reading up on this to see what is the hip chipset for the latest and greatest Intel, the latest and greatest AMD CPU. So when you look at all of this together, this is what makes chipsets work. Now, things have changed a little bit. Over the last few years, what we've seen is the function of memory controller. That has actually moved over to a new place. On most of today's modern CPUs, memory controller functions have been brought on board to the CPU itself. As a result of that, the whole idea of the two-chip system has begun to fade. And instead, what we tend to see today is a single chip scenario with usually some form of support chip. It's no longer the North Bridge, South Bridge thing. So the whole North Bridge, South Bridge issue has pretty much disappeared. And today, when we're talking about chipsets, we usually talk about a single chip solution with a couple of support chips to handle crazy things like RAID controllers and things that are often not necessarily part of the chipset itself. The bottom line is, you need to go out and you need to stay on top of the different type of chipsets that are available. That's what really defines the capability of a new motherboard.